So we want to look now at 24 on page 441, and we have negative x squared plus 2x, and they want greater than or equal to 0 this time. Okay, perfect. As you notice on the previous problem, this was nice. We already had it in factored form. The table does not work if we don't have the factored form. I can't use the table. So I have to use the factored form. I have to get the factored form first. Not a problem. I also see something that I don't like at all. The fact that there is a negative leading coefficient. So the negative leading coefficient has to go away to make my life easier. I'll multiply both sides by -1, and I get x squared minus 2x and 0. But something happens now. What?
The sign changes.
Excellent. Every time we multiply or divide both sides by a negative number of an inequality by a negative number, we have to switch the symbols. Very good. And now can you give me, can anyone give me the factored form of this while I get another sip of water? The factored form is? So the factored form is? Okay, the factor form is please.
X times x minus 2.
Very good. Indeed. Thank you. Now, because I have it factored, I can use the table. X is the variable in the problem. X happens to be, again, the first factor. X minus 2 is the second factor. But what I'm interested in is the product. Good. Then, what? These are my markers, so I can keep the paper in the view. X is, this is 0 when X is?
0.
Excellent. This is 0 when X is?
2.
Excellent. That's all I need. 0 and 2 in the correct order. 0 and 2. So then for X, I have 0 here. For X minus 2, I have 0 under 2. What happens to the product under 0 and the product under 2?
0, 0.
Excellent. So now I go back. They're all linear factors. First one. Does it look like this, from negative to positive or from positive to negative?
Positive.
Yes. We know that whenever the linear function has a positive slope, it's always the same. Now I have to establish the sign on the first subinterval. What will the sign be for the product?
Positive.
Very good. Awesome. In the middle?
Negative.
And outside. Very good. Now, again, this tells me what to pick. What sign is less than or equal to 0?
Negative.
Exactly. Here's negative, which means that this is the solution. We are asked to find x such that this is less than or equal to 0. So solution, x in the interval 0, 2. In the same identical way, before we look at problems in the book, identical way, let's solve a rational inequality. This is the last topic for test 2. Looking at 50. You can choose any problem. I just chose 50 for now, and then you can choose anything else. Okay, on 441. And that is 3x plus 5. Everything divided by 6 minus 2x. And they want greater than or equal to 0. Product or ratio perfectly work with the table. Product or ratio of factors. It's already done. I put it in the table. X is the variable in the problem. If I don't have here X, then I don't know where to put the value. So I have the top of the table has to be X at all times. Or whatever you have. If you have Y, you put Y. If you have Z, you put Z. The first factor is 3x plus 5. The second factor is 6 minus 2x. And finally, the ratio. 3x plus 5 over 6 minus 2x. Everything the same. However, there is a little catch, of course. In a moment, we'll get to it. So can anyone give us the value that makes this 0 and the value that makes this 0? Just set it equal to 0 and tell me what you get. And set the other one equal to 0 and tell me what you get. And in parentheses here, I'm going to write it in the correct order. This is very important to have it in the correct order so I don't make an error. In descending order, I meant to say.
Real quick, since you changed
Yes.
that, you have to change the one at the bottom too, the 6.
Oh no, this is just the original problem. No, I don't need
Okay,
that.
I just want to make sure.
Yes, very good. There is no need. You can if you want, but there is no need.
Maybe you'll still get the same answer.
Because 6 minus 2x is the same with negative 2x plus 6.
Okay.
Yeah. Good. So can anyone tell us the first x? Negative 5 over?
3.
Good. Can anyone give us the second x?
Three.
Excellent. Be very careful in ascending order. The first has to go in is negative 5/3. Sorry, my cough just switched the paper. So, and 3 in ascending order. I will put a 0 under negative 5/3. I will put a 0 under 3. Now, what happens for the ratio when x is negative 5/3, and what happens to the ratio when x is 3? Can anyone tell us? So when the numerator of a fraction is 0, what happens to the fraction?
It becomes 0.
Excellent. When the denominator of a fraction is 0, what happens to the fraction?
It becomes 0.
14.
Say it again.
Can you repeat the question?
Yes, I just want to know what happens to the ratio when x is 3.
14.
What happens to a ratio when the denominator is 0?
Undefined.
Thank
It's a
you.
whole.
It's a whole if in a different situation.
It's undefined.
It is undefined. Every time the denominator of a fraction is 0, the fraction is undefined. Agreed, everyone? Yes? Yes? No?
Yeah.
Yes. Okay, so let's go back and study the sign for each factor. So 3x plus 5, from negative to positive or from positive to negative?
Negative to positive.
Excellent. Good. For the denominator, from negative to positive or from positive to negative?
Positive to negative.
Awesome. Great job. I see 3 subintervals. 1, 2, 3. The first one, please. The sign. Notice that if you discuss the sign of a product or discuss the sign of a ratio, is the same thing.
Gonna be positive.
So I have the numerator, which is negative. I have the denominator, which is positive. What is the sign of the ratio?
Negative.
Excellent.
Negative.
Good. The numerator is positive, the denominator is positive, the sign is
Positive.
excellent. Numerator positive, denominator negative, sign.
Negative.
Excellent. Now, I go back here. And this time, I'm asked which sign, first of all, I'm asking you, which sign is greater than or equal to 0? Here we were asked which sign is less than, I was asking you which sign is less than or equal to 0. And I said it's negative. But now I'm asking something else. Which sign is greater than or equal to 0?
Positive.
Exactly. So let's take a look. Is this is our inequality, right? This positive. So is this ever positive? Is this ratio ever positive? Do you see the positive sign anywhere?
Yes.
Good. For which x value? Or x
2.
values? For which x values?
Negative 5 over 3. And 3.
Yes, but it's a interval. So negative 5 over 3, comma 3. Do I put a bracket or a parenthesis?
Parentheses.
Excellent. Why? I cannot put a bracket here. It's undefined. I cannot include 3. Great job. It has to be a parenthesis. That's it. There is nothing else from this section. Now let's practice with some graphs. This was the algebra part, but we can also read from graphs. So let's read from graphs. So we are given a polynomial and a rational. Let's choose one. Which of these two graphs you want to determine the positive and the negative, or whatever inequality we're asked to solve? Which one? The rational or the polynomial? Okay, I'll pick the polynomial. So let's look at 71 or 72. Okay, same thing, just one is greater than or equal to and the other one is less than. So 71 on page 441. We're asked to solve the inequality 2x cubed plus 11x squared greater than or equal to 7x plus 6. And of course, we are given the graph, so I have to have it on one side, I have to have 0. So I have to move these terms to the other side. So then 2x cubed plus 11x squared minus 7x minus 6 greater than or equal to 0. They're helping us with the graph. They are giving us this graph of 2x cubed plus 11x squared minus 7x minus 6. It's right here. I don't know if you can see. I hope you can see. 2x cubed plus 11x squared minus 7x minus 6. So the graph is here. And we're asked to find x values for which this graph has what sign? What sign is greater than or equal to 0?
Negative.
One more time.
Oh, no, positive.
Excellent. Good. So then we want to see where this function is above the x-axis. So follow the graph. From below the x-axis, above the x-axis, below the x-axis, above the x-axis. Since you said positive, perfectly correct. I'm looking for my pencil. So this is the positive for x between negative 1, 2, 3, 4, 5, 6, 7. Yes. So from negative 6 to, I want to say 1.5 approximately. From negative 6 to 0.5, the function is positive. From negative 0.5 to 1, the function is obviously negative. And from 1 to infinity, the function is positive. Also this side, from negative infinity to negative 6, the function is negative. I don't care for that. I just want positive. So I'm going to write between negative 6 and negative 0.5, union 1 to infinity. So solution. Negative 6. Let me count again. 7, 6. Yes, correct. Negative 6, negative 0.5. Since I have the equal symbol, I will use brackets. Union from 1 to infinity. So this inequality is a very difficult situation because I can't factor this. But I can also determine the solution from the graph. I'm given the graph, and this is the solution. Now, if I had the less than or equal to, of course, I will be using negative infinity to negative 6, union negative 0.5 to 1. That's where the graph is below the x-axis. Any questions? Any questions? So that's how we read or solve inequalities using a graph. Any questions? We only have 1 more minute, a minute and a half. So